So, hello everyone. Am I audible to you? Audible to you guys? Am I audible to everyone, guys?
இப்பதான் குடிச்சிட்டு வந்தாங்க.
So, I hope everyone is doing well in their preparation. So, today we are going to start our discussion on the topic of capsule and parentals. So, before starting, myself, Praveen Kumar, I'm currently pursuing my master's from the Naipar Pharmaceutics. So, let us start our discussion on the capsules and the parentals. So, let me start my screen sharing. Is my screen is visible to everyone? I hope screen is visible to everyone. So that's great. So, so capsule. So while coming to the GPAT and NIPER, the capsule topic plays an important role in every year. Approximately 2 to 3 questions are given from the capsule dosage form. This topic has a weightage from the 15 to 20 marks, and every year 2 to 3 questions are arrived. So let us deep dive into the topic. So let us understand what are the capsules. So capsules are nothing but similar as of like tablets is a solid dosage form in which one or more medical or inert ingredients are enclosed in a gel-like structure, which is known as capsule. So generally, it is made up of gelatin. Most of the, as you can see that in market, we see many types of capsules. So most, approximately 80% of capsules are made up of gelatin. So it consists of a shell in which the powder, it can be powder, it can be liquid, or it can be semi-solid. So these are the different types of materials or the formulations which can be prepared and can be filled into the capsules, and capsules can be administered. So these are the quite advantages of the capsules, as we can know that they can increase their bioavailability, they can mask the taste and odor of the unpleasant drugs, they are easy to swallow. So while coming to the disadvantages, so guys, say me why what is meant by the efflorescent substance? Come on, guys, say what is meant by the efflorescent substance. Do you guys know what is meant by the efflorescent substance? What is meant by fluorescence? Efflorescence. Okay. Okay. So efflorescence and deliquescence. So these are the two types of terminologies which have to be kept in mind and should have to not get confused between these two terms. So which produces CO2 is nothing but effervescence. Efflorescent is different one. So efflorescence is something which releases the water from it. For example, a compound has a water, yes. If, for example, if a compound has a water, if it removes its water, which is present in its crystal lattice, then it is known as efflorescent substance. So as we know that the gelatin itself consists of a moisture. So if we pack any efflorescent substance in the capsule, the substance will release its moisture and the capsule will absorb it, by which the whole shell will become soft. That's why the efflorescent substance are not packed or given in the form of capsules. And what is about deliquescence? So guys, tell me about what is meant by deliquescence. So deliquescents are the materials which absorbs the moisture from the environment and convert into a solution form. For example, NaCl. Absorbent, yes. These are the materials which absorb the moisture from the environment and become solutions. By which, when we pack such a kind of materials, deliquescent materials in the capsule, they absorb the moisture which is our present in the capsule. They absorb the moisture from the capsule, by which capsule whole become hard. That's why efflorescence material and deliquescence materials are not packed in the capsule dosage form. And some of the materials like potassium chloride, potassium bromide, and ammonium chloride are also not packed in the capsule dosage form because those are irritant to stomach. So, and next coming to the most important topic or the most important sections of the capsule is the types of capsule. So while coming to the majorly in the market, two types of capsules are available: soft gelatin capsule and hard gelatin capsule. So guys, could you please say me that which type of capsule can be divided into two parts? Hard gelatin capsule can be divided into two parts, or soft gelatin capsule?
Hard gelatin.
Hard. Okay. So hard gelatin capsule consists of two parts. So it consists of a body and it consists of a body and head. The hard gelatin capsule
इसी
consists of two parts,
वो
body and
रेज्यूमे
head.
का लिंक कैसे
Generally, the height of the body is larger when compared to the head. So the main difference, the difference between two capsules is very important, guys, because I think so in NIPER 2023, they have asked the question about the difference. So while coming to the differences, generally soft gelatin capsule has the more concentration of plasticizer when compared to the hard gelatin capsule. So can anyone know the ratio of the plasticizer versus gelatin in the soft gelatin capsule? Do you guys know the ratio? The ratio of the plasticizer versus gelatin in the soft gelatin capsule? Yeah, it is 0.8 is to 1. Great, great guys, great. And while coming to the hard gelatin capsule, it is 0.4 is to 1. So let me add the text for. So here 0.4 is to 1, while in the soft gelatin capsule, it is 0.8 is to 1. So by which we can know that the plasticizer content in the soft gelatin capsule is high. That's why which provides the plasticity and softness to the gelatin capsule. Next, this is the disintegration time. The disintegration time of soft gelatin capsule is 60 minutes and disintegration time of hard gelatin capsule is 30 minutes. This is very, very important, guys. You have to remember these values. Next, while coming to the moisture content, being more soft in nature, the soft gelatin capsule only consists of moisture from the 6 to 10%, while hard gelatin capsule has a moisture content of 12 to 16%. And what is meant by bloom strength, guys? What is meant by bloom strength? Do you guys have any idea about the bloom strength? What is meant by bloom strength? Do you guys have an idea about the bloom strength? Cohesive strength, oh, great. So bloom strength. So bloom strength is another most important thing or the parameter which is to be studied while coming to the capsule dosage form. So bloom strength measures the rigidity or cohesive strength. Nice. So its value generally ranges from the stiffness of the gelatin. So it measures the cohesive strength. The cohesive strength between the gelatin. Between the gelatin strings, it measures the cohesive strength between the gelatin. So which is termed as bloom strength. So generally, provide me guys, which of the following capsule has the highest bloom strength? Is the soft gelatin capsule has the more bloom strength or hard gelatin capsule? Come on guys, it's a revision for you guys. Say me that which of the following capsule has the more bloom strength? Hard gelatin capsule or soft gelatin capsule? Yeah, the hard gelatin capsule has the more bloom strength. Generally, it ranges from the 200 to 250. While for the soft gelatin capsule, it ranges from the 50 to 100. Most probably, it consists of 100. So generally, soft gelatin capsule has the higher bioavailability when compared to hard gelatin capsule, and the soft gelatin capsule is less prone to the changes in the weight variation and the content uniformity. So generally, whatever we see the vitamin capsule, so whatever the liquids are filled in the soft gelatin capsule, while the powder, etc. materials are filled in the hard gelatin capsule. So let us have talk about the some things about the types of gelatin. As we have, guys, whoever is speaking, try to mute yourself because it's disturbing the class. So while coming to the types of gelatin, generally two types of gelatins are available in the market and are used for the capsule preparation, which are known as type A gelatin and type B gelatin. So type A gelatin are obtained by the acid hydrolysis of the animal skin, generally pig skin, and it has a pH of 1 to 3. While coming to the type B gelatin, it is alkali treated. It is alkali treated, and generally it is has source from the green bones. So it is very important, guys. I think in GPAT 2022 or 2021, they have asked about the source of the type B gelatin, which is green bones. Green bones. So while coming to the type A gelatin, the source is pork skin, pig skin, which is known as. So the isoelectric point of the type A gelatin is 9, while coming to type B gelatin is 4.7. So say me, guys, what is meant by isoelectric point? Isoelectric point for the proteins. What is meant by isoelectric point? Do you guys have idea about the isoelectric point? Yeah, I will gonna share this PD. I will gonna share this. Okay. So isoelectric point is nothing but the pH where the number of carboxylic groups and amine groups get equal in the protein. So the net charge becomes neutral. So the charge of type A gelatin is cationic in nature. Type A gelatin is cationic in nature. Type B gelatin is anionic in nature. So this is also to have to remember, you guys. These both the type, the differences, the isoelectric point. It is acid treated while it is alkali treated. Isoelectric point. So these are the some of the important points which have to be kept into mind and have to get revised. Next, another important capsule manufacturing steps. So for the preparation of the hard gelatin capsule, we have the different manufacturing steps, which include dipping, spinning, drying, stripping, cutting, and joining. So while coming to the dipping, so guys, could you please tell me for how much time the dipping process takes place? The time period of dipping. Do you guys have idea how much time the dipping process takes place? This has been asked in the NIPA 2023. Yeah, 12 seconds. So dipping process takes place for the 12 seconds. 12 seconds. It's not 15 seconds. It is 12 seconds. And it is dipped into the gelatin solution, which is maintained at the 50 degrees Celsius. The temperature of the pin, see guys, these parameters are very important. The temperature of the pin is 22 degrees Celsius, while the temperature of the solution is 50 degrees Celsius. And the time for which the dipping process occurs is 12 seconds. Next, spinning. In spinning step, the whatever the pins which are dipped into the gelatin solution are rotated so that uniform spreading occurs throughout the pin. So this is the pin, and it is rotated so that throughout the pin the gelatin solution get attached. After that, we take out the pins from the gelatin solution and we dry it. Then we strip by bronze jaws. So this is very important, guys. Bronze jaws. Next, we have to do the trimming, joining, and polishing. So polishing. So provide me, guys, how do we do the polishing of the capsules? Can anyone say me how do we do the polishing of the capsules? How the capsules are polished? Do you guys have any idea? Coating material. Yeah. Could you please mention the name of that coating material which is used for the polishing? Acryla Kota, yeah. That is the equipment name. So I will mention select. So no. I will mention the name. So generally for polishing, NaCl is also used. Sodium chloride is also used. Along with that, we can also use the polyurethane cloth. Polyurethane cloth, or we can use the polyurethane cloth, or NaCl is generally used for the polishing of the capsules. So this whole process takes only 45 minutes, guys. Here you have to also remember the time for which the process takes place. The whole process of preparation of capsules takes around 45 minutes. So next, acid alkali treated. I have said you. Okay. So next, the capsule number. the capsule number is very important, guys. The 000 is the highest number, while 5 is the lowest number. So the capsule size of 000 is the largest capsule, while the capsule size of 5 is the smallest capsule. So guys, here you have to remember any one number, any one. You can remember the content in the ml or by content in the mg. So if you remember the content in the ml by dividing it with zero point 0.8, you can get the content in the mg, because as we know that the density is equal to mass by volume. So the density of the gelatin is zero point 0.8. So by which we can get the, by multiplying the ml content into the zero point 0.8, generally we can get the content in the mg. So try to remember this value. This value is very, very important. These make ask that what is the content of the capsule number 1, capsule number 4. So you guys have to remember any one thing, mg or ml, which is very important. And also based upon shape, the sizes also can be given. So for example, the round capsules have size of 9 minims, while coming to the oval capsules are 16 minims, while coming to the oblong capsules, it is 20 minims. So this is also one of the important, guys, you have to remember. So for the human use, the maximum size which can be used for the human use is only 0. The 00 and 000 are generally used for the veterinary purpose, guys. So next coming to the, so alternative material for the hard gelatin capsule. So in most of the cases, we only use the gelatin for the preparation of hard gelatin capsule. But along with that, there were many research have been conducted, and also the starch hydroxylate was also used to prepare the shell of the capsule. HPMC is also used. Poland, Citosan, Pondac, etc. were also used to prepare the shell of the gelatin. As I mentioned, the polishing way. So next, this is very important, guys. The names of different machines which are used for the filling in the capsule. So generally, remember, guys, Rotafill is used for the pellet filling. Rotaweight by name we can mention the weigh. So it is a high-speed capsule weighing machine, guys, which is used to weigh the capsules. Next, Vericaps. Vericap is also same thing. It is used for the sorting the capsules based upon the weight. So, do you guys know any difference between the Rotaweight and Vericap, guys? There is a slight difference in the principal difference between the two both, Rotaweight and Vericap. Do you guys know? Do you guys have any idea between the different, what is the main difference between the Vericap and Rotaweight? So let me say you. So in Rotaweight, the capsules are weighed based upon the X-ray. Here the X-rays are used to weigh the capsules. While in Vericap, the dielectric constant is parameter is used to weigh the capsules. So this is the difference between the two equipment, guys. In Rotaweight, the X-rays are used, while in Vericap, the dielectric constant is used. So next, as I mentioned, the rotafill, which is used to fill, this is the equipment which is used to fill the pellets in the hard gelatin capsule. Next, aquafill. Aquafill is equipment which is used to fill the powder in the hard gelatin capsule. There is also one equipment which is known as aquagel. Aquagel. Can anyone say me what is the purpose of the aquagel, guys? What is the purpose of the aquagel equipment? Do anyone know the what is the main aquagel? Soft what? So yeah. So it is used to fill powder in the soft gelatin capsule, guys. The aquagel is used to fill powder in the soft gelatin capsule. These equipments names and their function is very important, guys, because every year there can be a possible question from this portion also. Next, this is another important condition. Generally, the capsules are stored at 35 degrees Celsius. The processing area should be 22 degrees Celsius, and the humidity should be maintained throughout the capsule manufacturing, guys. Because slight change in the humidity can lead to affect the integrity of the capsule. So another, the moisture content is determined by toluene distillation method. This is very important, guys. The moisture content of the capsule is determined by the toluene distillation method. Next, while coming to the soft gelatin capsule, so soft gelatin capsule, uh, as I mentioned, the bloom strength or the gel strength, which is nothing but the measurement of the cohesive strength of the cross linking between gelatin molecules, and it is directly proportional to the molecular weight of the gelatin. So here it comes the most important parameter. The gelatin has the constant, the gelatin concentration of 6.66% weight by volume kept at 10 degrees Celsius for 17 hours is used to measure the bloom strength, and it is measured by measuring the weight in grams required to move a plastic plunger of here some of the parameters which have to be remembered in bloom strength, which are the diameter of the plastic plunger, which is 0.5 inches. So what is done is in a bath, the gelatin solution is taken and a plastic plunger is kept dipped into the gelatin solution. The solution has the concentration of 6.66% weight by volume. The temperature of the solution is 10 degrees Celsius for 17 hours. So the plunger which is dipped into the gelatin solution for the measurement of bloom strength has the diameter of 0.5 inches in diameter, and it is dipped up to the 4 mm depth. So next, by which the bloom strength or gel strength is determined. So generally the range of the bloom strength depends from the 150 to 250 grams. Next, iron content. So iron content of the capsule should not be more than 15 parts per million according to the Indian Pharmacopoeia. And as we can know that the bloom strength determines the quality of the capsule, and the capsule which has the highest bloom strength is more of quality, and the cost of the capsule also increases with increase in the bloom strength. So could you guys please say me that what is the viscosity of gelatin which is used for the capsule manufacturing? Could you say me the range of the viscosity? Do anyone have idea, or do anyone can able to recall the viscosity limit range of the gelatin? Yeah, 20 to 25 to 40. I want with millipoise or centipoise or what are the value? Yeah, millipoise. So yeah, great guys. I think you are able to get your revision back. So viscosity. So viscosity of the gelatin, it measures the molecular chain length. It is also determined at 6.66% at 60 degrees Celsius. And generally the optimum viscosity required to produce a non-tacky, non-brittle shells are 25 to 45 millipoise. So here the note, guys. This note is very important. So low viscosity and high bloom strength gelatin is used for the hygroscopic materials. As I mentioned, guys, what is difference between the hygroscopic and deliquescent? Guys, do you know the difference between the hygroscopic and deliquescent? As I mentioned, the deliquescent material should not be filled into the capsule. So what is the difference between the hygroscopic and deliquescent? So deliquescent materials are those which absorb the moisture and become the solutions, while the hygroscopic material only absorbs the moisture and which only leads to the increase in the weight of the material. That's it. This is only the main two difference. So next, another most important component of a capsule cell while coming in the soft gelatin capsule is plasticizer. So plasticizer impact the softness, improve the flexibility, elasticity, and pliability of the cell. Whatever the gelatin. So generally used is the glycerin, polyhydric alcohol. Sorbitol is one of the most widely used as a plasticizer. Next, polyethylene glycols are also used for the capsule. So as I mentioned, the ratio of the triglycerin to the trigelatin, this is also very important, guys. For soft gelatin capsule, it's 0.8 is to 1. For the soft gelatin capsule, for the medium hardness capsule, it's 0.6 is to 1, and hard material is 0.4 is to 1. So while coming to the other components of the capsule, which includes preservatives. So preservatives most widely used are methyl paraben and propyl paraben. So provide me guys, which of the following is the water soluble? Methyl paraben or propyl paraben? Say me guys, which of the following is a water soluble? Is methyl paraben is water soluble or propyl paraben is water soluble? Try to answer my question clearly. Which of the following is a water soluble? More water soluble comparatively, methyl paraben or propyl paraben? Think guys, think. Which of the parabens is more soluble? Methyl, yes. The methyl paraben is more soluble, water soluble than propyl paraben. Generally, the concentration of the methyl and propyl paraben is usually in 4 is to 1. Yeah, nice. So due to the one carbon extra, it which increases the hydrophobicity, which leads to decrease in the water solubility. So methyl and propyl paraben concentration is 4 is to 1, or it can be used in the 0.2 percentage. 0.2 percentage. The other preservatives it can be used as butyrated hydroxy anisole, butyrated hydroxy toluene, EDTA, and sodium benzoate. Next, fumaric acid. So fumaric acid is also used in the soft gelatin capsule cell in order to decrease the aldehydic staining of the gelatin. Next, flavoring agent is used as ethyl vanillin. Sulfur dioxide is used to prevent the decomposition of gelatin. Opacifier is used as titanium dioxide. Flavors, as I mentioned, the ethyl vanillin essential oil. Anti-caking agent, if you are filling any suspension in the soft gelatin capsule, to prevent its formation of cake, we can use the anti-caking agent in the formulation, which includes the silicon dioxide, humectant, which is used humectant. So, guys, could you please say me the what is role of a humectant? Do anyone know what is meant by humectant or what is the role of humectant? Role of humectant. Do you guys know humectant role? Role of humectant? Prevent moisture loss. Yes. It prevent the humectants prevent the moisture loss from the surface of the gelatin and it maintains the integrity of the gelatin. So, and generally used humectant is the polyol, but along with it, sorbitol, glycerin are also used as the next buffers. So buffers generally use the sodium phosphate, which is used to prevent maintain the pH of the solution. So while coming to the base adsorption, so another important term generally which is have to be studied in the capsule, which is said as base absorption. So base adsorption is nothing but the minimum gram of the quantitative parameters used to determine the minimum capsule size for the encapsulation of suspension formulation. So but in sometimes we don't know that how much capsule size is sufficient for our suspension. In that case, we have to calculate the base adsorption. By calculating the base adsorption, we can able to determine the capsule size for our suspension formulation. So generally, higher the base adsorption value, smaller will be the size of the capsule. So it is mentioned that the number of grams of liquid base that is required to produce a capsulable mixture when mixed with 1 gram of solid. For 1 gram of solid, how much liquid base is required so that it can be mixed with that solid so that it can prepare a capsulable mixture. So generally the most important formula for the base adsorption is weight of the base by weight of the solid. So for example, for a solid, if the base adsorption value is lower, then the density of the mixture will be higher and smaller will be the capsule. And also the base adsorption value depend upon several factors such as hydrophilic, lipophilic nature of the solid substance, its particle size, physical state, density, moisture content, etc. So these are the different parameters which influences the base adsorption value. So as I mentioned, this point is very important, guys. Lower the base adsorption of a solid, higher will be the density of mixture, hence the smaller will be the capsule. So next we have to go and discuss about the iron content should not be more than 15 parts per million. These have to be remembered by you guys. And generally, the soft gelatin capsules are prepared by these processes. plate process, rotatory process, reciprocating dye process, and aquagel process. As I mentioned, that aquagel is used to cap fill the powder into the soft gelatin capsule. So another types of equipment which is auger type or auger type machine, which is from the two from Eli Lilly. It is used to fill the pellets. Here I am talking about the equipment, guys, and the Hall Finger and Kong type, which is used to fill the powder, pellets, and thixotropic materials. Sometimes the antioxidants are also used. So antioxidants are also used. Could you guys please say me any example of any antioxidant? What are the examples of the antioxidants? Do you guys able to remember or recall the BH3, BHA? Great, guys. Sodium benzoate are also used as okay. So next we are coming to the quality control test of the capsules. So generally this is for the dissolution. Which apparatus is used for the guys? For the dissolution of the capsules, USP, which type of dissolution apparatus is used? Can you able to recall, guys? Type 2. Type generally type 2 of IP and type 1 of USP, you use it for the capsules. Type 2 of IP, type 1 of USP, which is basket apparatus, is used for the capsule dissolution. Yes. So another a problem which occurred during the dissolution of the capsule is the formation of pellicle. Pellicle formation during the dissolution of the capsules, which leads to decrease in the dissolution of the drugs. So this is the one of the extra point which I have to provide you guys. The pellicle formation of dissolution of the capsules during the dissolution, which leads to decrease in the dissolution. Next, the other wait guys, 1 minute. Next, the content uniformity test. So, do you guys able to remember the how many capsules are taken for the content uniformity test initially? Can anyone say me how many capsules are taken for the content uniformity test? 20. I think in starting the 30 capsules are taken, and from 30 capsules, yes, the 30 capsules are taken. So let me provide you the whole rationale. First, the 30 capsules are taken. From the 30 capsules, only 10 are taken for the study. 10 capsules taken from the 30 batch. And these 10 capsules are then performed for assay. After performing assay, 9 must contain drug content from 85 to 115 percentage, and not less than 1, not less than 1, and none contain, and no capsule should contain below 75 to 125 percentage. For weight uniformity, how many capsules are taken, guys? For weight uniformity test, how many capsules are taken? Could you guys please tell me for weight uniformity test, how many times? which is nothing but weight variation test. How many capsules are? Yeah, 20. So 20 capsules are taken and the weight variation test is performed. So disintegration test is also performed. So could you please tell me what is the mesh size of the disintegration test? Mesh size in disintegration test 10. Okay, great. So what is the disintegration time of soft gelatin capsule and soft hard gelatin capsule, guys? As I mentioned earlier, provide me the disintegration time of soft gelatin capsule and hard gelatin capsule. Soft gelatin capsule 60, hard 30. Great, guys. I think you are able to recall all your concepts, and that is a great, guys. So for the weight variation, for the weight variation, if the weight is less than, if the contents are less than 300 mg, then the weight variation value is 10%. If it is greater than 300 mg, then it is plus or minus 7.5%. So now I think let us now discuss some of the MCQs related to the capsules. So let me show you guys some of the MCQs related to the capsule. Wait a minute. Provide me, guys. Provide me answer to this question. Which of the following is not a type of capsule cell? Answer this question, guys. Answer this question. Everyone, I want everyone's involvement in this question to be answered. Not visible. Not visible. Okay, okay, wait a minute. 1 minute, 1 minute. Okay, wait. Let me share me. Is it visible now, guys? Everyone is visible? Is it visible to everyone? So answer this question. Which of the following is not a type of gelatin capsule, not a type of capsule cell, guys? Everyone. I want answer from the everyone, guys. Yeah, great. The answer is D. Next, which type of capsule is mostly suitable for the highly potent and moisture sensitive grass? Highly potent and moisture sensitive. Try to read the question properly, then answer it, guys. Try to understand the question because this year all questions will come in the form of conceptual way. The correct answer is soft gelatin capsule. Next, what is the primary purpose of adding plasticizer to the gelatin capsule? Gelatin gel of the capsule. Provide me answer the primary purpose of adding plasticizer to the gelatin shell of the capsule. Great, guys. Improving the cell stability and flexibility. Next question. Which of the following is a disadvantage of the HPMC capsule compared to the gelatin capsule? Provide me the answer to this question, guys. Everyone, try to read the question, understand the question, apply your concept, then answer the question. Answer to the last question. What would be the possible answer to this last question? Which of the following is the disadvantages of using HPMC capsules compared to the gelatin capsules? Try to read the question. The answer is A. It has a limited compatibility with wide range of drugs. The answer is A. So, yeah. So, now let us start our discussion. I think so everyone is clear with the capsule. Do anyone has any doubts related to the capsule chapter? So that I can move into the next chapter, which is parenterals. Anyone has any doubt related related to the capsules so that I can move to the next? Okay. So let us start our discussion to the parenterals. So parenteral. So what do you mean by parenteral, guys? So parenteral refers to the, it is derived from the Greek word para and enteron, means administrating something, the drug outside the GIT tract. Something which is not given to the GIT tract is termed as the parenteral. So preparations given other than oral route administered with the help of injection. The routes bypass the alimentary canal. So the term parenteral literally means to avoid the GIT tract and refers to any administration route outside the alimentary canal. So parenterals are the injectable drugs that enter the body directly and do not require to absorb from the GIT tract. They show their effect. So while coming to the parenterals, there is a no step of the absorption. So parenterals have the rapid onset of action than the other route of administration. So generally pyrogens. So could you please provide me, guys, which gram positive bacteria produces the pyrogens or gram negative bacteria? Gram positive bacteria or gram negative bacteria? Great. So gram negative bacteria produces the pyrogens, and pyrogens, I think so, these are the lipopolysaccharides and which induces the fever in the person. So these are the generally advantages of the parenteral route, where it has the complete bioavailability, 100% bioavailability, avoid fast pass metabolism, sustained delivery, which where we can use the long-acting injectables, usually in the emergency solution, rapid onset of action. These can be known. So while coming to the disadvantages, pain, yeah, obviously the pain occurs. Uh, Trained personnel are required for the production of the injectables. The high aseptic conditions should be maintained. Chances of improper dosing, danger of blood clot formation. So these are the some of the disadvantages of the parenteral route. So these are the routes by which the different routes by which the drugs can be administered to the patient, which includes subcutaneous, intramuscular, intravenous, intradermal, intraarterial, intraaortic, intrathecal, intracistermal, peridural, and intraarticular. So first come to our discussion to the subcutaneous. Sir, in subcutaneous, could you please provide me the angle by which the administration occurs in the subcutaneous? Provide. Do you guys able to recall 45 degrees? Great, guys. So the given at the angle of 45 degrees, and it is directly administered into the fatty tissue. As we can see, this is the layer of our skin. This is epidermis, dermis, subcutaneous, and muscle. So directly the fatty tissue. In the fatty tissue, the drug is administered. So generally, not more than 1.5 ml should be injected to this side. So administered below skin. So generally 25 or 26 gauge needle is used, which is of 3 by 8 or 3 by 8 to 5 by 8 inch. Because this is the subcutaneous. So generally oily solutions and aqua suspensions are used. And do you guys have known about the process hypodermoclysis? Do you guys able to recall the process hypodermoclysis? Do anyone know about what is meant by this hypodermoclysis process? Do anyone know about this process? So in hypodermoclysis, what we do is, in order, what is happened that in subcutaneous, only the small volume of the solution can be injected. So in order to overcome this process, what we do is we inject the hyaluronidase enzyme, which destroy the hyaluronic acid which is present in the fatty tissues, which opens the fatty tissue, by which more amount of drug can be administered into the subcutaneous. Next, intramuscular. So intramuscular is given to the upper and outer portion of the gluteus maximus, larger muscle on the outer side of the buttocks. For children, IV injection is given to the deltoid muscles on the shoulder. Could you guys say me that vaccines are administered by which route? Vaccines. Vaccines are administered by which route? Can anyone able to recall the vaccines are administered by which route? Great, guys. The vaccines are administered by intramuscular route. So generally, and provide me the angle of intramuscular injection. What is the angle of intramuscular injection? Great, guys. Great. 90 degrees. So by 90 degrees, the intramuscular injections are given. Generally, the gauge of the injection is 20 to 25. The needle is half to 1 inch needle. Next, intravenous or infusions. Yeah, BCG is given through the intradermal. Nice, guys. For the testing of the allergic testing. So intravenous fast acting because it is directly given into the vein bloodstream and often it is used in the emergency determined in critical areas. Provide me the angle of the intravenous injection, guys. Intravenous injection angle. Intravenous. I'm not talking about intramuscular. Intravenous. Yeah, 25 degrees. Nice, guys. 25 degrees. 25 degrees. So generally 25 degrees for the fluid and electrolyte replacement it is used. It also to provide the vitamin, mineral and nutrition to the patient who is critically ill. The intravenous injection is given. Guys, do you know difference between the IV bolus and IV infusion? Can anyone say me the difference between the IV bolus and IV infusion? IV bolus and IV infusion. Provide me difference between the IV bolus and IV infusion, guys. Fast. What is difference between the IV bolus and the IV infusion? In IV bolus, once administered while IV, yeah, great. So in IV bolus, for the small volume parenterals, the IV bolus is used, and for the large volume parenterals, the IV infusions are used. Where in IV infusion, at constant amount of drug is administered every time. Next, while coming to the intra-arterial, so intra-articular directly given into the artery, intracardiac where we give the drug solution into the heart muscle or ventricle at the time of emergency only. Intra-apical, which is given into the subarachnoid space surrounding the spinal cord, spinal anesthesia. So intracisternal injection, which is given between the first and second cervical nerve and used for the cerebrospinal fluid for the diagnostics purpose. Next, while coming to the peridural injection, it is given between the dura mater and the inner aspect of the vertebra. So these are the general requirements for the parental preparations. It may be stable, it should be sterile, it should be free from pyrogens, it should be free from foreign particles, it should be isotonic, specific gravity, and chemical purity. So formulation. So now we are going to talk about the formulation aspects of the parental products. So first one, vehicle. So vehicle generally which is used to solubilize the drug. So mainly two types of vehicles are used: aqueous vehicle and non-aqueous vehicle. So aqueous vehicle generally used are water for injection free from carbon dioxide, and non-aqueous vehicle includes ethyl alcohol, propylene glycol, almond oil, etc. Most of the cases, whichever by IV route, when we administer the drug solution, it must be in the solubilized form. So in order to increase the solubilizing, we can use the solubilizing agents like queens and polysorbates. Generally, non-anionic surfactants are only injected. Anionic and cationic surfactants may cause irritation. That's why these are not administered. Only non-anionic surfactants are administered via injectable route. Next, we can use the stabilizers or antioxidants. These are the quite few examples which you have no, guys. Next, buffering agents. Buffering agents generally are used to maintain the buffer. So, could you guys say me which are the buffering agents is generally not administered, not used for the injectables? Which buffer is not applicable for the injectables? I want the name of that buffer. Could you guys able to recall that type of buffer which is not used for the injectable? I can able to recall it's quite borate buffer. Borate buffer is not used for the injectable, guys. Remember that point. Next, antimicrobial or anti-agents can be used generally for the bacteriostatic water for injection consists of benzyl alcohol. Chelating agents can be used EDTA. Sometimes for the nano suspensions or nano emulsions, we can use the suspending agents or the emulsifying agents. Tonicity contributors. In order to maintain the isotonic, we can use the sodium chloride and dextrose. So before going to the detail in the formulation, I would like to discuss some of the things which is termed as small volume parentals and large volume parentals. Small volume parentals and large volume parentals, LVP. So small volume parentals are generally single dose or multi-dose, guys. Say me, the small volume parentals are single dose preparations or multi-dose preparations. Small volume preparations. Small volume preparations. The small volume preparations are the multi-dose preparations. Multi-dose preparation, guys. Yeah, less than 100. Great, great. These are the multi-dose preparations. Multi-dose preparations, while the large volume parenterals are the single dose preparations. So generally, up to what is the limit? Okay, less than 100 ml. So less than the 100 ml of the small volume parental and more than 100 ml is the large volume parental. So next, we can say that in which do we require any preservatives in the large volume parentals? So I have an MCQ for you guys. Wait a minute. Which of the following? 1 minute, guys. Which of the following preservative is used in large volume parentals? A. Benzyl alcohol. Cresol. C. Sodium benzoate. D. None. Provide me answer to this question, guys. Which of the following preservatives is used in the large volume? Everyone should answer to this question. Great, great, guys. Great, great. Yeah. So in large volume parentals, no preservative is used. No preservatives used. Great, guys. I hope you can able to recall your all your concepts through this discussion. So while coming, as I mentioned, vehicles. So generally, majority of the weight of an solutions. Yeah, no buffers also. Yeah, great. So in small volume, parentals multi so required preservatives. Yeah, say great. Because many times you have to take the drug and you have to administer. So during which it can be lead to the microbial growth. So to avoid that microbial growth, preservatives are added in the small volume parentals. So next, vehicles. So vehicles contribute to the higher proportion in the preparation. So there can be these are generally excipients. It is also one of the excipients. So excipients do not possess any activities or no therapeutic activities. And these are non-toxic. Absorption occurs rapidly when drug is admission in solution form. Yeah. But isotonicity and pyrogenicity must be present in the large volume parentals. So I'm going to start the discussion on those also, isotonicity and pyrogenicity. So types of vehicle used as aqueous vehicle, water miscible vehicles, and non-vehicle. So these, I think so. You guys know about the aqueous vehicle, water for injection, sodium chloride injection. These are the example. So and here the important discussion which I have to take is aqueous vehicles difference. So let me 1 minute, guys. Is it visible to everyone? The whiteboard is visible to everyone? Is the whiteboard is visible to everyone? Yes. Okay, great. So generally, let us start our discussion first the water for injection. So these are the very, very important guys. The parameters for the each and every vehicle is very important and everyone must remember. And now guys, you will answer my all my questions. Say me guys, water for injection is prepared by which method? Water for injection is prepared by which method? Come on guys, fast. Water for injection is prepared by distillation and reverse osmosis. Distillation and RO. Reverse osmosis, which is termed as reverse osmosis. And it must be pyrogen free, which is a criteria of the every injectable. Pyrogen free. Provide me the total organic carbon content for the water of injection. Could you guys able to remember the total organic carbon content of the water for injection? Total organic carbon content. Come on, guys. Come on. It's your revision. What is the total organic carbon content of the water for injection? No. No. It is 0.5 mg per liter. Next, another important total carbon content, which is which should be less than it should be less than 500 parts per billion. Guys, provide me the endotoxin limit. Endotoxin limit. Endotoxin limits in the water for injection. Provide me the unit. How many units? What is the limit of the endotoxin limit unit in the water for injection? Recall, guys. Remember. Recall. Everyone must have to revise their concepts. What is the endotoxin limit in the water for injection? It is 0.25 units per ml. You have to remember this all these unit guys. Next, total solid content. What is the total solid content? Not yeah, great. 10 parts per million, not greater than 10 parts per million. Great guys, great. Conductance, do you know the conductance? Conductance value? Conductance value? Conductance value? It is generally less than 1 micro ohm per centimeter. Less than 1 micro ohm. 1 micro ohm per centimeter. So these are the all parameters which are to be studied for the water for injection. Next, we'll talk about the sterile water for injection. If the water for injection is there is no criteria that it must be sterile. So if we sterilize the sterile water for injection, then it becomes the sterile water for injection. So it is also prepared by the same method, distillation and reverse osmosis. It is pyrogen free, but it is sterile. So it is guys saying sterile water injection should be stored in single dose containers or multiple dose containers. Am I audible to everyone? Is my voice is audible to you guys? Okay. So provide me the sterile water for injection. Is it stored in single dose container or multiple dose containers? Sterile water for injection, it is stored in single dose container. It is stored in single dose container. Provide me the solid content, guys. Everything remains same. Hello, I'm audible. Sorry, guys. As my network was lost. Am I audible, guys? Am I audible to you guys? Am I audible? Is it now also breaking, guys? Is my voice is also now also breaking? Okay, great, guys. So sorry for the interruption, guys. It was due to the network issue. Okay. So I think it is visible to you guys. So I was discussing about the sterile water for injection. So sterile water for injection, it is stored in the single dose containers, is not stored in the multiple dose. So provide me the total solid content of the powder for sterile water for injection, guys. Total solid content. Do anyone know the value of the total solid content from the sterile water for injection? Okay. Can anyone able to recall it? So let me say you guys. So if the volume is 30 ml, then it is 40 parts per million. If it is 30 to 100 ml, then 30 parts per million. If it is greater than 100 ml, then it is 20 parts per million. So these are the some of the values which have to be remembered, guys. Next, bacteriostatic water for injection. What is meant by bacteriostatic water for injection, guys? What is difference between the normal water for injection and bacteriostatic water for injection? Can anyone provide me the difference between the bacteriostatic water for injection and normal water for injection? Come on, guys. I want everyone to be interactive in the class. What is difference between the bacteriostatic water for injection and normal water for injection? That was noted. Preservatives, yeah. Preservatives are added in the bacteriostatic water for injection. So it can be used for the both single dose and multiple dose. So generally, most widely used preservatives is the benzyl alcohol. It is used in the 0.5 percentage. 0.5 percentage benzyl alcohol. So next, so I think this is clear to everyone. This is very important, guys. These are the some of the. So now moving our discussion to the vehicles I have mentioned. So water miscible vehicles. So pyrogen free sterile water for injection, as I mentioned. Water for injection that has been sterile and packed in the container 1 liter or less. Pyrogen free. No antimicrobial preservatives or added substance are added in the sterile water for injection. Due to sterilization, may contain slightly more solid content. So next, bacteriostatic. It contains bacteriostatic agents when in containers less than 30 ml or less. When the content is 30 ml or less, the bacteriostatic agent is added. So the adequacy of water purity is demonstrated. So water purity is measured by these methods, which I mentioned. Microbial contamination, where the total viable count should be not more than 10 colony forming units per 100 ml. As I mentioned, the bacterial endotoxin limits with 0.25 per ml. Due to some reasons, the fluctuations are occurring, guys. So sorry for the inconvenience which is caused. So osmosis. So osmosis is generally, as we know that the osmosis. So osmosis is a process by which the molecules of solvent tend to pass through semi-permeable membrane from the less concentrated solution to the more concentrated one. So less concentrated means the solution which contains more amount of water to the less amount of water to semi-permeable membrane. For this osmosis, the most important part is semi-permeable membrane. But in reverse osmosis, by adding the external water, we do the reverse. The solution movement occurs from the highly concentrated one to less concentration one in the pressure in the presence of external pressure. So generally USP permits to storage. So with when you prepare the water for injection, it should be used within the 24 hours. And it's when the water was cannot be used at the 80 degrees Fahrenheit, heat exchanger must be installed to reduce temperature point of use. Next, most important topic while coming to the injectables is the pyrogens. So pyrogens, as I mentioned, these are the lipopolysaccharides and these are the metabolic products of the microorganisms. So most pyrogens are the endotoxins and these are the constituents of the cell wall of the gram-negative bacteria. Example, Pseudomonas, Salmonella, Escherichia coli, E. coli. While the gram-positive bacteria produces the exotoxins, while the gram-negative bacteria produces the endotoxins. So generally, the pyrogens are soluble, filterable, and thermostable. They can able to withstand the 120 degrees Celsius for the 3 hours. So endogenous pyrogens, the exogenous pyrogens. So this is not important, guys. So additives, as I mentioned, the antimicrobial agents. The antimicrobial agents are generally added to prevent the growth of the microbial agents. So different examples of the antimicrobial agents which are used are 0.01% benzoathonium chloride, 0.01% of benzalkonium chloride, phenol, cresol, chlorobutanol. So these are the generally units. So next, while coming to the mercuric compounds, phenyl mercuric nitrate most frequently employed is used in the 0.002 percentage because as it contains the concentration of mercury, that's why it is used in very less concentration. Next, stabilizers, as I mentioned, that stabilizers are used to ensure the stability of the drug compound in the preparation. As we can know that the drug in the solution form is more prone to degradation while coming to the drug in the solid form. Next, antioxidants. Antioxidants are also used. So provide me, guys, as I have you been going through the antioxidants. So generally, the antioxidant class is divided into four. First one, reducing agents. Do anyone know the examples of the reducing agents? What are the examples of the reducing agents under the class of antioxidants? Examples of reducing agent, guys. Sodium metabisulfate, guys. Sodium metasulfate, say great. Ascorbic acid, etc. Great, guys. Great. Next, blocking agents. Examples of blocking agents. Yeah, ascorbic acid, ester, BHT, BHA, propyl gallate, tocopherol. These are all the examples of the blocking agents. Next, synergist. Examples of synergist, guys. What are the examples of the synergist? Citric acid, phosphoric acid, citrochronic acid, tartaric acid, etc. Next, chelating agent, most popularly known as EDTA. And also in formulation of the injectables, two other excipients are also used, which are known as cryoprotectants and lyoprotectants, guys. Cryoprotectants and lyoprotectants. So as yeah, DMS. So the cryoprotectants generally most of the powders which are reconstituted for the injection route are prepared by the process of lyophilization. So yeah. So do anyone can able to recall what is meant by the lyophilization? What are the synonyms of the lyophilization? Could anyone say me what is the synonyms of the lyophilization? What is meant by lyophilization? Freeze drying. Great, guys. Freeze drying. So generally in lyophilization, we do the freeze drying. So during freezing, our drug may not get damaged. So in order to prevent the drug from the freezing step, we use the cryoprotectants. And in order to protect the drug from the drying stage, we use the lyoprotectants. So generally used cryoprotectants are sucrose. Provide me the examples, guys. Sucrose, trehalose, glycine, lysine, mannitol, sorbitol. Mannitol, sorbitol, these are the different examples which are used for the cryoprotectants, lyoprotectants. So next, isotonicity is most important for the parental solutions. And as you maintain the tone, solution should have the same osmotic pressure. So what happens when we keep our blood cells in the hypotonic solution? Say me guys, what happens when we keep blood cells in the hypotonic solution? Swelling followed by bursting. Great guys. Next, what happens when we keep our drug, our blood cells in the hypertonic solution? Hypertonic. Shrinking. Yeah, great guys, great. So in hypertonic solution, this leads to shrinking, which is also known as crenulation. Which is also known as crenulation. So generally, do anyone can able to remember the osmotic pressure of the blood? Do anyone can able to recall the osmotic pressure of the blood? What is the osmotic pressure of the blood? Osmotic pressure of the blood in mmHg. Osmotic pressure of the blood in mmHg. Yeah, 7.7 atmospheric pressure. So generally isotonicity, which is very important. Yeah, great guys, great. So tonicity is very important. So tonicity is maintained by the sodium chloride. Tonicity adjusters include most probably include sodium chloride. So what is the concentration of sodium chloride which is isotonic with blood? Provide me 0.9%. What? Weight by volume by volume. What? Provide me the total 0.9% weight by weight or weight by volume or volume by volume. Great guys, great. Weight by volume. Great guys, great. So as I mentioned, these are the different additives which are used in the uh, as antioxidants. Next, buffers. As I mentioned, as we know that buffer something which is able to resist the change in pH. So buffer system should have low buffering capacity, should not disturb the body buffering injector. So most widely used are citrate, estates, and phosphates. So provide me the example of amino acid which has the inherent property of buffering capacity, guys. Which amino acid has the buffering capacity? Histidine. Great, guys, great. As I mentioned, the examples of the cryoprotectants and lyoprotectants. So next, chelating agents. So chelating agents generally trace concept heavy metals can be catalyze the degradation. So in order to prevent the EDTA, so ethylene diamine tetraacetic acid has how many binding sites? EDTA has how many binding sites? 6. Great guys, great. Next, great. Solubilizing agents. So solubilizing agents are also used for the in order to increase the solubility. So wait. So here the important one comes. So let me give you a first blank slide. Okay. Let me share a whiteboard to you guys. next most important thing which I have to discuss with you guys. Glass containers. Glass containers. Yeah, great. Glass containers. There are four types of glass container: type 1, type 2, type 3, type 4. Type 1. Type 1. What is what is the name of the type 1 glass? Now you have to answer to all my questions, guys. It is a rapid revision one for the glass containers. The type 1 glass is also known as. The type 1 glass is also known as. Come on, guys. Type 1 glass. It is borosilicate glass. Type 2 glass. Soda lime treated glass. Soda lime.
Yeah, treated soda lime glass. So am I audible to you guys? 1 minute. The whiteboard is loading. So type 1 glass is the treated soda lime glass. Type 2 glass is the treated soda lime glass. Type 3 is the soda lime glass, and type 4 is the 1 minute, guys. Hmm. So glass containers. So type 1 glass is generally used for the buffered and unbuffered solutions, while the type 2 glass is used for so generally composition of the glass. So glass is made up of silica pure, soda ash, limestone, and cullet. Cullet is also used as fusion agent for the broken glass. Generally for the unbuffered and buffered. So type 1 glass is generally used for the preparations that are intended for the parental administration. So type 1 glass has the highest resistance to the uh, leaching. While coming to the type 2 glass, which is soda lime treated glass, so which is generally used for dye powders and oily preparations. While type 3 glass is generally used for the non-aqueous parenterals. Dye powder. So generally for the parentals, type 4 glass is not used. Because same test is done, and for the type 1, 3, 4, which test is done. For type 1, which test is done, and for type 2, 3, 4, which test is done. For type 1, which test is done. Type 2 water cat, yeah, great, yeah. Great, guys, great, great. So hydrolytic resistance test. So for the yeah, type 2 water test, type 3 broken glass test, which is also powder glass test, which is also known as powder. So the other tests which are used for the evolution of the glass are the leakage test, internal bursting pressure test, thermal shock test, chemical resistance of the glass test, arsenic test, and hydrolytic resistance test. So this is not important, guys. The going to in detail is not important. Let me start. Plastic containers, pyrogen. Okay. Let me give the that due to the pyrogen test. Wait, I think so. This is now evolution plastic. No. Let me start a screen sharing so that I can give you guys. So first one, pyrogen test. So don't try to write anything on the board, guys. I'm trying to present it. So first one, the different evolution tests for the uh, parenterals includes the package integrity test, pyrogen test, clarity test, and sterility test. So while coming to the package integrity test, which includes the different tests, which includes first one, the bubble test, leakage test. In the leakage test, which of the following dyes is used, guys? In leakage test, which dye is used in the leakage test? Methylene blue. What is the concentration of methylene blue in the leakage test? Leakage test, methylene blue concentration. Methylene blue is used. Great, guys. Concentration. In which concentration? Methylene blue concentration. 1%, 1%, 1%, 1%, 1%, 1% is used. Next, while coming to the visual inspection, so pyrogen test is generally done by the rabbit test and the LOL test. So what is meant by LOL, sir? LOL, LAL, Limulus amoebocyte lysate. Great, guys. So it is horseshoe crab. I can able to, okay, guys, you can able to recall what is meant by horse. Is it horseshoe crab? Horseshoe crab, which is Limulus polyphenus. So let me LOL test. So pyrogen test is done by LOL test, where uh, obtained from the horseshoe crab. Horseshoe crab. The name is Limulus polyphenus and Pachyphyllus. Pachyphyllus. Try. Then, yeah, kinetic chromogenic test. Great, guys. Great. So pyrogens, I have mentioned the end. Next, while coming to the sterility testing, sterility testing. So sterility testing, this is two type. Type A, which is membrane filtration method. Filtration method. So the sterility test type A is membrane filtration test, while type B is direct inoculation test. Inoculation test. So bigger test. So for vials and bottles, the other tests which are used as water hammer test, and spark test are used for testing integrity. Next, while coming to the clarity test, Clarity test. Guys, could you able to say me? For particle size of 10 micrometer or greater, for particle size 10 micron or greater, what is the limit of the solid content, guys? Can anyone say me? Great, 50. So 50 particle per ml. Great, great. If the particle size is 25 micron or larger, 25 micron or larger, then 25 micron or larger, then how many particles? Not more than how many particles? 5. Great, 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 great. 5 particle per ml. And particle size of 50 micron or larger, nil. Great, guys, great. So generally the membrane filtration test and the membrane filtration test and the direct inoculation test are done for the 14 days, guys. This should be remembered, 14 days. So in leakage test, the pressure which is applied is minus 140 mm Hg. Vacuum is created which is minus 140 mm Hg. It should be remembered, guys. So now let us have some of the MCQ discussion related to parenterals. So let me frame one MCQ for you guys. Let's see how you answer it. For HEPA filter, what is its efficiency? So let me move to it, guys. Efficiency. Efficiency. Okay, great. Let me first write the question. 99.97 percentage of particle, zero point 0.5 micron, 99.98 percentage of particle, 0.3 micron, 99.97 percentage, 97 percentage of particle. Wait, guys, wait. Let me complete my question. Of 0.3 micron, the 99.99 percentage of particle of 0.3 micron. Great, guys, great. It is option C. Great. So let me another thing. So that's all for the today, guys. I hope you guys have been clear with your concept. If you have any doubts related to the parental, do you guys have any doubt related to parentals? Any doubts? Any doubts? So I'm gonna share this PPT to you guys and the also the whiteboard and the further MCQ related to the parentals will also be posted. So where you can solve the MCQs related to parentals also, guys. So I hope this session was helpful to you guys. and you have been revising. The revision has been help you guys. Everyone must revision because this is one of the crucial time. You have only 1 month, guys. So only the things which you have to do is revision and attempting the mock test. That's it, guys. You have to revise all the topics where we have to gonna take all the topics in the class. We have to be interactive with us, with the educators, where by which you can also get revise of your topics and get clear of your concept, guys. So thank you everyone for joining. Let's meet you in the next class, guys. Thank you. Thank you, guys. Thank you.